Hello friends, continuing with electrostatics, first chapter, charges and fields. Today we take up second topic, Coulomb's law. Before we start with Coulomb's law, we are to understand certain terms. First term we are to understand is point electric charge. What is a point electric charge? The charge with dimensions very small as compared to separation between them is known as a point electric charge. What is point electric charge? The charge with dimensions very small as compared to separation between them is known as point electric charge. Here you can see the size of the charge is very small as compared to the distance between the charges. So we say all these charges are point electric charge. Point electric charges. Now, second term we have to understand is charge distribution. What is a charge distribution? How we define it? Charge distribution. When charge has dimensions more than the separation between them. When charge has dimensions more than the separation between them, then charge is said to be continuously distributed. Now see here is a charge distribution along one dimension. Another is charge distribution along three dimensions and two dimensions. Another one is the charge distribution along two dimensions. Now the third one is charge distribution along three dimensions. Here you can see it is charge distribution along one dimension, it is charge distribution along two dimensions, and here is charge distribution along three dimensions. Now we take up one by one. Type of charge distribution, as we have already discussed. Three types of charge distributions are there. Okay, three types. One is linear charge distribution, the other is surface charge distribution, the third one is volume charge distribution. As we have seen above in the previous slide, the diagram of linear charge distribution, surface charge distribution and volume charge distribution. Now we take up one by one. First we take up linear charge distribution. Linear charge distribution, how we give definition to linear charge distribution, that we are to understand now. When charge is continuously distributed along one dimension, the kind of charge distribution is said to be linear charge distribution. I repeat, when charge is continuously distributed along one dimension only, the kind of charge distribution is said to be linear charge distribution. Now here is the linear charge distribution diagram. You can see it is of length L. Now linear charge density. We have to define linear charge density. What is linear charge density? Let us look at next slide. Linear charge density, lambda. First we talk of linear charge density. We did study it. First we have the diagram here. Consider this diagram, linear charge density. How we define linear charge density? Let us give its definition. The charge per unit length at a point over linear charge distribution is defined as linear charge density. Now we talk of mathematical expression. How we write mathematically about linear charge density, lambda, expression for lambda. Now consider if Q be the total charge in linear charge density of length L, then linear charge density lambda according to definition will be equal to Q by L. Okay, and its SI unit will be coulomb per meter. What will be SI unit? Coulomb. Q has unit coulomb and length has unit meter, so it is coulomb per meter. Now, total charge in linear charge distribution Q will be equal to lambda into L, or integration lambda dl. Okay. So, this is how we understand about the definition and mathematical expression. Now, we come to second distribution, surface charge distribution. Now, we have to look into surface charge distribution and the way we have looked into linear charge distribution. All those points in order we have to discuss here also. Now, what is definition? When charge is continuously distributed along two dimensions only, the kind of charge distribution is said to be surface charge distribution. Okay, here you can see is the surface charge distribution. The charge is distributed along two dimensions. Now, we have to understand about surface charge density. Now, surface charge density, how we study surface charge density, the method is same. Here is the surface charge distribution diagram, and now we talk of definition. Charge per unit area at a point over surface charge distribution is defined as surface charge density. Okay. Charge per unit area at a point over surface charge distribution is defined as surface charge density. Now, how we write mathematically? If Q be the total charge in a surface charge distribution of area A, then surface charge density sigma is equal to Q by A. Sigma is the symbol for surface charge density. Here, sigma is equal to Q by A. Now, SI unit. What is SI unit of surface charge density? SI unit. SI unit is coulomb per meter square. SI unit is coulomb per meter square. Okay. The total charge in surface charge distribution is equal to sigma into A. Sigma into A. Now, here you can see total charge is sigma into A, or we can write integration over S surface sigma ds, or we can write integration sigma dl, 2 times integration over length. Okay, 2 times integration over length. So, we write Q equal to sigma A, or equal to sigma ds over surface S, or integration over L sigma dl. So, this is how we can understand about surface charge distribution. Now, we come to volume charge distribution definition. When charge is continuously distributed along 3 dimensions only, the kind of charge distribution is said to be volume charge distribution. Here you can see in the diagram, charge is distributed along 3 dimensions. So, we can say it is a volume charge distribution. Okay. Now, we come to volume charge density. Volume charge density rho. Okay. Now, we have to define it. What is the volume charge density? How we define it? Let us see the definition. Charge per unit volume at a point over volume charge distribution is defined as volume charge density. I repeat, charge per unit volume at a point over volume charge distribution is defined as volume charge density. Now mathematical expression. Now if Q be the total charge in a volume charge distribution of volume V, then volume charge density rho is equal to Q by V. SI unit will be coulomb per meter cube. Now total charge in a volume charge distribution, Q is equal to rho V. Q is equal to rho V is equal to integral rho dV over volume V, integral L rho dl, means integral over length rho dl. So this is how we can write total charge in a volume charge distribution. Q is equal to rho V is equal to integral over volume V rho dV is equal to integral L integral over length L rho dl. And now we come to XII. Question number 1. Define point electric charge. How charge distribution is different than it. Illustrate by diagrams. Question number 2. Define a charge distribution. Illustrate various charge distributions by diagrams. Question number 3. Define linear charge density and give its SI unit. Write the expression of the total charge in a linear charge distribution in terms of linear charge density. Question number 4. Define surface charge density and give its SI unit. Write the expression of the total charge in a surface charge distribution in terms of surface charge density. Question number 5. Define volume charge distribution. Give its SI unit. Write the expression of the total charge in a volume charge distribution in terms of volume charge density. Okay, so these are 5 questions that you have to answer on the basis of the text you have learned. And thank you so much. Next time we'll take up Coulomb's law.